Hello, and welcome to your 1412 mini lecture on polyprotic acid equilibrium. Polyprotic acid equilibriums work in much the same way as monoprotic acid equilibriums. The difference is that monoprotics need one rice table, and polyprotics need two or sometimes three rice tables. There will be a table for every proton which comes off of the acid in an equilibrium fashion. For protons that come from a strong acid, there is no such equilibrium. An example is sulfuric acid. The first proton which comes off of sulfuric acid is a strong acid proton. Whatever the initial molarity is of sulfuric acid, that goes to zero, and the initial molarities of the first conjugate acid and hydronium are equal to that initial concentration. The second proton which comes off of sulfuric acid will need a rice table. It is not a strong acid proton and will reach an equilibrium state. Carbonic acid takes part in two successive proton transfer equilibria. The conjugate base of carbonic acid in the first equilibrium, hydrogen carbonate, acts as an acid in the second equilibrium. That ion produces in turn its own conjugate base, carbonate. Notice, the acidity decreases significantly with each successive proton loss. Another way to say that is Ka1 is much, much greater than Ka2. At the beginning of a reaction, or initially, there are only reactants present. The concentration of the first reaction products are zero. As the reaction goes forward, reactant concentrations will decrease as product concentrations increase. The amount of change is not known, so it is called X. The reactant in this reaction will have a negative X written in the change box. The two products will each have a plus X written in their boxes. Note, the coefficient of the species in the balanced reaction becomes the coefficient of X in the table. This is why it is so important to write the coefficients in the top line. To get the fourth line, simply add together the second and third lines. The results will represent the equilibrium concentrations of all species in the equilibrium expression in terms of the initial concentration and X. Set the equilibrium expression equal to the equilibrium constant, which will be provided, and then solve for X. Plug X back into each equation in the bottom row to get the equilibrium concentrations of all species in the reaction. Here is the new part which comes into play with polyprotic acids. The equilibrium concentrations found by plugging X back into the last line of the first table are equal to the initial concentrations of the second table. The concentration of the second table products do not start at zero. This is key. This slide has an X in the second table, but when you work the problem, the X will have been substituted for and will not appear in the second table. In general, you will find that the initial concentration of both acids in both tables will simply be the initial concentration given once you take into account the approximation of small x or y. The values of the products will be the thing which comes from the calculations. This has been your 1412 mini lecture on polyprotic acid equilibrium. Please go to your homework and complete the associated assignments at this time. If you run into trouble, please ask for help. Help is always available.